let's take a look at
Problem number 12, which kind of follows along the same data set. It says for the car speeds of exercise 10, recall that the mean speed recorded was 23.84 miles per hour, and the standard deviation was 3.56. So here's our n, 23.84, 3.56. To see how many cars are speeding, John subtracts 20 miles per hour from all speeds, because the speed limit is 20 miles an hour. He doesn't just want to know how fast cars are going. He wants to know how many cars are going faster than the speed limit. So he just subtracts the speed limit from all the different scores that he had, all the different data scores. And the question is, what would the mean speed be now? This is number 12. Well, if you recall, if we subtract the same number from all of our data points, our mean, which is a measure of position, is going to change by that exact same number. So I had 23.84 as my mean. I'm subtracting 20 miles per hour as to see who's speeding, who's going over. So my new mean is going to be 3.84 miles per hour. The mean is 3.84 miles per hour above the speed limit. That's what's going on here, why we subtracted that. And the second part of this question, A, says, what is the new standard deviation? Well, standard deviation doesn't change at all. Standard deviation is going to stay at 3.56. It's just like when we had a histogram of our heights, if you recall. If we add 4 inches or we subtract 4 inches, the only thing that's going to happen is that the histogram is going to shift right or left. It's the same thing with our speeds. Our histogram is going to shift right or left, but the standard deviation, that is the spread between data points, isn't going to change at all. The standard deviation is going to stay at 3.56. The next part of question 12 says, well, the guy who measured this has a friend in Berlin who wants to study the speeds, so he converts all of the original miles per hour readings to kilometers per hour by multiplying all the speeds by 1.609, which is the kilometers per mile. So there's 1.609 kilometers in a mile, and instead of having this in miles per hour, he wants it in kilometers per hour. So the question is, what's the new mean going to be? Well, if I'm multiplying by something, I have to multiply the mean. I have to multiply all these different data speeds that gave me the 23.84 average, multiplying each one of those, which were in miles, by 1.609, so that I can get them into kilometers. Well, so my new mean, let's put it out, is going to be 23.84 times 1.609. So our new mean, we're going to have an n. Our mean is going to be 38.36. What about our standard deviation? Is that going to change? It sure enough is, because we're multiplying now. We're not just adding or subtracting, we're multiplying. Our standard deviation was 3.56 miles. Now we want our standard deviation in kilometers. So we're going to have to do the same thing for the standard deviation. 3.56 times 1.609. Our new standard deviation, 5.73. 5.73. So that is our new normal model if we changed over to kilometers.